as you and I get more and more ability, more skills and knowledge and practice with networking, the better and better we're going to get at it. Not just the configuration of it, but also the troubleshooting. If we know, or we can predict the behavior of the network as a packet starts from here and goes to there, then if that breaks or doesn't work, we can logically go through those steps or that process to see where it broke down. Well, inside of Packet Tracer, there is a simulator option where we can actually take a look. We can send traffic through the network in our Packet Tracer network. We can see the results of it. We can also stop it along the way to take a look at the details of those packets. This simulation option is going to blow your socks off. It's so darn fun. I'd like to introduce it to you in this nugget. And also, as we go through these videos together, I'm hoping that you're taking a moment or two to have installed Packet Tracer and following along and getting the hands-on practice. Because once we're done with the videos in this skill regarding using Packet Tracer, it's going to unlock the doors of lots of possibilities as you practice and gain additional skills with other Cisco devices as well. So without further ado, let's take the topology that we've built so far as part of these nuggets, and let's go ahead and send some traffic over them and watch how Packet Tracer can elaborate and enumerate on exactly what's going on every step of the way. So here is our topology, and we don't have any IP addresses configured yet. So to get some basic traffic, if it's IP traffic, we need to create some IP configuration. So what we'll do as part of our plan, in fact, let's go to our whiteboard. So as part of our plan, let's do this. Let's take this PC, which is connected to the switch, which is connected to the other two switches, which is connected to the router, and let's use the 10.67.83 network with a 24-bit mask, and let's configure the PC to be .100 and the router to be .1 on this interface right there. And then we'll just do some basic, maybe a ping between the PC and the router. And that way we can visually see the traffic as it goes across the network, and Packet Tracer will reveal that to us. So with this network in mind and those IP addresses in mind, let's do the basic config on the PC and also on the router. This will also serve as an opportunity to see how that's done on these devices in Packet Tracer. And my intent is for you to do this alongside me. So let's go ahead and configure the PC and the router. So let's start with the router with its gig 00 interface. It's already up. We brought that interface up in a previous video as part of the skill. And so we'll click on R1, bring it up. We'll press enter and then type in enable to go into privilege mode. They'll type in configure space terminal, or config T for short. And then we'll go into interface configuration mode for gig 0/0. And we'll give it the IP address using the IP address command of 10.67.83.1 with a 24-bit mask. And that's how we spell 24 bits in dotted decimal, and press enter. And that part is done. We should also verify that. We'll do a show IP interface brief just to verify that we have the IP address that we think we do on the correct interface. So we double check our work. That looks fantastic. And let's go configure PC1. So we'll click on PC1. I'll go ahead and bring this over a little bit. We'll click on config, and we'll click on interface FA00, and we're going to configure a static address, and that's going to be 10.67.83. What address did I decide on? Let me go take a look at my notes for a second. Okay, it was .100, fantastic. So we'll put 10.67.83.100 with a mask of 255.255.255.0. Looks great. And then one thing about Packet Tracer is there's no apply button. If there isn't an apply button, it just took it. So we'll go ahead, and with that done, let's go to the desktop. So this is representing this PC1, and let's go to a command prompt. So we'll click on command prompt, and we'll type ipconfig just to verify that we have the IP address that we think we did. Great, 10.67.83.100, and let's do a ping over to the router at 10.67.83.1. And you know what? I've been doing networking for a while, and I'm still excited when I do a ping, just thinking I think it should work. And when it comes back, if it does work, it's great. So let's go ahead and verify whether or not we can get a ping from the PC all the way over to the router and a response back. So we'll press enter, and yes, reply, reply, reply. So there's an echo request that went out and a response that came back. Fantastic. We've got basic connectivity. Also, I'm going to use this opportunity to show you how to save a project. So what we're going to do is we're going to click on File, and then click on Save, And if you've already saved it under a name, it just updates that. So it's important to save your work as you go. We have basic connectivity between the PC and the router. Now, for the piece de resistance, and that is the simulation. What we're going to do here is we're going to go ahead and take our mouse in the lower right-hand corner, and we'll just click on this icon here for simulation. Now, by default, it's going to include a lot of information that it's going to visualize. But what I'd like to do for now, just for a simple demonstration, is I'd like to go ahead and have us click on Show All/None. You click on that once, it removes everything. You click it again, it shows everything. I'd like us to click it and have us not show us anything. And that way we can be very specific about what we want to see in the visualization. So currently I have no visible events, none. And also, I'm going to go ahead and take off this constant delay, remove that check mark. So it's on by default. And then we can either play the simulation or we can step it through one by one. So having done that, let's add a filter that's going to allow us to see the specific traffic that we want to see in this simulation. And I would recommend, because we just verified that ping works, which is using ICMP, that's IP protocol number 1. I'm not sure how it was so lucky. Anyway, what we want to do is we're going to click on Edit Filters. And we have IPv4 information, IPv6 information, miscellaneous, including protocols. So let's click on IPv4 and say we just want to see ICMP by putting a check in the checkbox next to ICMP. And we'll go ahead and we'll close that. And when we do, you'll notice over here, it now says in the event list, filters, visible events, ICMP only. So any ICMP traffic that goes through, we should be able to see it. So let's do this. There's actually several ways of launching this. One way is to use this icon right here. This envelope with the little plus symbol, that is to create a simple PDU. PDU is an acronym for protocol, data, unit, some information we're going to send. And the one to the next is a complex PDU with lots of options and bells and whistles. For now, let's just do a simple PDU. So we're going to click in this little envelope here for simple PDU. And then we're going to specify where do we want to go from and where do we want to go to. This is going to create a ping request between the source and destination. So what we're going to do is we're going to drop that on PC1 as the source, and then we're going to move our cursor over to R1 as the destination. And now this is our PDU that's going to be generated. So we have this little envelope, this little package, a packet that's going to be sent by PC1 to the IP address of R1. And it's up here in this simulation panel. So if I move this over a little bit. So because I don't have it on auto, we can click on play, or we can just step it through one step at a time. So if we click on this step through option on the right here, if I click that once, that packet moves from PC1 to the access layer switch, and there it sits. So in the course of learning Cisco and networking in general, what we're going to learn is that different network devices move data in different ways. So a switch, a layer 2 switch, makes forwarding decisions based on MAC addresses. So if we open up this packet, in fact, let's do that right now. I'm just going to double click on it right here. And that opens up the packet at that point. And it's showing right here the information that's in that packet. So fast Ethernet 0/1 receives the frame on this access layer switch. I'm going to click next layer. This is a unicast frame, meaning it's going only to one specific destination as opposed to a broadcast or a multicast. So the switch looks in this MAC table to see, hey, do I know how to forward this? So then the switch is going to forward that in the appropriate direction. Based on this topology, it's going to forward it from the access switch out FA 0/2 up to the core 1 switch. So I'm going to go ahead and close that window, and then we'll continue our simulation by clicking on this next step icon right here. So we'll click on that. And then we'll step it through one more time, and that goes to R1, who receives it. He's happy about it because it was destined to him. He de-encapsulates it, looks at it, and says, oh, this is a ping request. And as a result, he's going to do a ICMP echo reply, a response back to PC1. And we can see that as well just by clicking on the continue button. So there's the response. Also, down here at the very bottom right, there's a left arrow, little area right here. If we click on that, so it hasn't completed yet because the response hasn't made it all the way back. And that's why it's showing us that this simulation is currently in progress. If we continue that, it goes down back to the access layer switch and then back to the PC. And that, my friends, is how we can do a simple simulation, a simple PDU with ICMP and then visualize that and see it happen. And if we want that to happen again, we can go ahead and click on Reset Simulation. And if we want to hit play this time, it'll just play the whole thing. And this speed control right here will control the speed of how fast it goes. So if we want it to go faster, we can increase the speed, and it will increase the speed of the animation for us. So let's do one more. I'm going to go ahead and toggle the Show All, Show None to go ahead and clear out the filter. I'm also going to click on the simulation here and click on Delete to remove it from there as well. And let's add ARP. ARP is a very common protocol in IPv4. It's when a device needs to discover the layer 2 or the physical or MAC address of another device on the local network. And so if we click on Edit Filters and we put in ARP, that will allow us to only see ARP related events. Now the next question is, how do you create an ARP related event? Well, one is we could go to this PC, and on this PC, if we tried to ping ping to 10.67.83.99, there's no device on this network has the host address of .99. And so the PC doesn't know that yet, but the first thing that the PC is going to have to do is figure out, hey, what's the layer 2 address associated with this IP address? And because it's on the local network, there will be an ARP request and an ARP reply if that device is there. In our case, there's no device there, so it'll just be an ARP request. But we should be able to see it with the simulation. So I'll press Enter to go ahead and run that, and check this out. Here's our simulation right here. This is the ARP request. I still have it. I'm going to step it through. So I'm going to go ahead and click on Advance. That goes to the switch. The switch says, well, let's take a look at the packet. If we double click on this, and it brings up the packet, the destination is a broadcast. And that broadcast for the switch, it says, okay, I need to forward this to everybody. Everybody, it could be anybody on this network. I need to forward it to everybody. And the switch is going to go ahead and forward it as a broadcast. So if we click on the next step here, it sends that broadcast both to core 1 and to core 2. And then as we continue to play that out, I'll go ahead and put it on autoplay now. As that continues to play out, everybody on that network in that VLAN has seen that broadcast. Unfortunately, no one on this network has that IP address, and that's why there's no response. There's no response coming back. And if we wanted to reset that, we could just by clicking on Reset, and then we could also change the filters again to go ahead and turn it off. So the cool thing is we can see tons and tons and tons of different types of protocols in action on the network and verify them as they're happening. So this is and will be an amazing tool that we can use as we take a look at networks and we predict, okay, I think this is what's going to happen, and then taking a look at the details, and if it doesn't match what we anticipated, that's a great opportunity to say, oh my gosh, that's what happens, or that's how it works. Or if we're focusing on layer 2 switching and taking a look at MAC addresses involved in a layer 2 frame that's being sent, or routing decisions, and with NAT, how that IP address is changed as it goes across the boundaries of a NAT router. Those are all really interesting things to see and verify. And Packet Tracer, which is so easy to access, can be a great tool in that learning. So thanks for joining me in this nugget. In the next nugget, I'd like to walk you through using an advanced or a complex PDU where we're actually testing apps and services more than just a simple ICMP in the simulation option inside Packet Tracer. So when you're ready, I'll see you in that video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.